Welcome back to the channel, guys. And today we'll start our DSA in Java, the language in which you can become Android engineer or a backend engineer or even a software engineer. So, let's start. Now, you might be having a question, why Java? As I already told you, you can become three kind of engineers just because of Java. You can learn Spring Boot and become a backend developer. You can learn Kotlin and become an Android developer, or you can just learn more about Java and become a software engineer in legacy organizations like Jenkins or Apache. They all have code written in Java, and AI is pretty bad at it, I would say, because that is legacy and old code, and AI is just not able to do it. So let's first see how Java actually works. So in Java, you will first have just a normal .java file, which will be given to the compiler. Now, what is a compiler? A compiler is a piece of software, you can say, that compiles your entire file into some other kind of language, which has some patterns in it, so that it can be further interpreted by the machine. But in Java, the compiler is not converting your code directly into machine code. It is rather converting it into another kind of code, which is bytecode. And it has the extension of dot class file. So your dot Java got converted into dot class. Now this dot class file is a platform independent file, which is interpreted by another piece of software, which is called as JVM interpreter. Now what this JVM interpreter will do is that it will take your dot class file. Now, once it takes your dot class file, it is going to execute that file line by line by converting it into machine code. And then on the machine using CPU, it is going to be executed. Now, this bytecode file is the reason that we say Java is platform independent. Now, what do you mean by platform independent? Platform independent means that there is one person who is using Mac, there is another person who is using Windows, and there is another third person who is using Linux. Now you write Java code just once on any of the system, and you can just compile this Java code and you will get a dot class file. Now you just need to install the JVM interpreter on all the three devices, which is platform dependent. For Mac, the JVM interpreter will be different. For Windows, it will be different because it will then communicate to the hardware or the operating system level things. So this dot class file will go into Mac OS. Now Mac OS will see that it has JVM interpreter. Now this JVM interpreter will then interpret your dot class. This makes your uh, Java language a platform independent language. Okay, so let's see more about platform independence. As I already told you, it means that the bytecode can run on all operating systems. We just discussed it. Now, what is actually happening is that you have a source code in Java language. Now, that needs to be converted into machine code so that it can be executed on machine. What C++ and some other languages do is that they directly convert it into machine code, and therefore they are not platform independent because the machine code that they're converting it into is platform dependent. It needs to know what kind of operating system or hardware it has to run. But what Java does is that the compiler of Java is going to convert it into bytecode, which is platform independent, and then it is going to give it to all the operating systems that want to execute it. And all those operating systems will have what? They will have JVM interpreter. And that JVM interpreter will convert that bytecode into machine code and it will just run on that operating system, which means that our Java becomes platform independent. So let's see the structure of our Java. Now, the outermost thing that we have is JDK. JDK is Java Development Kit. It consists of two things. One is our development tools that we use, and the another thing is Java runtime environment. Now, for a Java program to run, you need to have a runtime environment and development tools also, like IntelliJ IDEA or something. I basically run my Java code on IntelliJ IDEA. You can use Eclipse also, and even online compilers. So JRE is Java runtime environment. What it does is it is consisting of two things. One is your JVM and one are your library classes. For example, you are not going to write whole code from scratch in machine code, kind of like the low level development that is done. You're not going to write key how the input should be taken from your keyboard. You're just going to use a scanner class, and with the help of that scanner class, you can take input like normally. You can just write on the keyboard and the input will be taken. But what is happening under the hood is being done by the library classes. That is what, along with the JVM, consists of your JRE, which is Java Runtime Environment. Then we'll come to JVM. Now, I already told you that JVM is an interpreter. What it does is the bytecode that you get after a compilation, it will interpret it line by line. After interpreting it line by line, it is going to convert it in machine code. Then we have JIT. JIT is just-in-time compiler. Now, what JIT does is key when the JVM interpreter is interpreting a code, it might happen that it is having more than same line of code, same piece of code at more than one places. For example, there's a function. Now, what is a function? A function is a piece of code which is written in such a way that it can be reused again and again. So just imagine that your program is calling a function 3 to 4 times. Now what JVM will do, it will interpret the same function 4 times, but that will cost you time and also effort by the machine, which is just a wastage of your resources. So what JIT will do, it will store the repeatedly code that is being interpreted in the memory, and instead of interpreting it again and again, JVM will take that code from JIT and it will put it in there where the interpretation needs to be done. That is our whole structure. We have JDK. JDK consists of JRE plus development tools. Then JRE consists of JVM plus your library classes. And then JVM consists of your JIT, which is just-in-time compiler. So what is JDK actually? So JDK is going to provide you the environment where you can develop and run the Java programs. It is a package that includes development tools, JRE, your compiler, archiver, your docs generator, and your interpreter. So JDK has everything that you need for complete Java development from start to the end. Development tools are going to be your IDE kind of things, like VS Code. VS Code you might have used. So for Java, we usually use IntelliJ IDEA, which is from JetBrains. We have JRE, which is there to execute your program. Now we have a compiler which is called as Java C, or you can say Java. So Java C compiler is the compiler that compiles your Java code. Then we have a archiver also, which is your jar archiver. Now these are some things that you don't need to know about until you are doing pretty good level of development. Then for generating the docs also, you have Java doc, and then you have your interpreter or the class loader. What does loader do? It loads the classes that are required at the time of compilation. So now if we come to JRE, JRE is what? It is an installation package that is going to provide the environment that is necessary to run the program. It consists of your development technologies, your user interface toolkits, base libraries, JVM, and integration libraries. So it is just a combination of various toolkits and libraries and JVM. So when does JRE actually comes into the play? So when you have a dot class file, what is the dot class file? It is your byte code. When you have a dot class file, the class loader will load all the classes which are needed to execute the program. Sorry, which are needed to execute the program. Then the JVM, it is going to send that bytecode verifier. Now you have bytecode. So firstly, your JVM will verify it, whether it is, corrupted or something. And after verifying and checking the format of the code, it is going to start the interpretation line by line. So we saw JRE, which is a subpart of your JDK. JDK is your development kit. JRE is your runtime environment. Now, what is actually happening? Let me show you. So, firstly, at the compile time, you have a dot Java class. Then you have the Java-C compiler, which is converting your .java file into a dot class file. So JVM execution will happen after that. So at the runtime, what is happening? Runtime started. Then there is a class loader which is going to load all the classes necessary for that program to run. Then the bytecode verifier will come into the action. It will see whether the dot class file which you have given is it in the correct format. From there, if it is verified, then your interpreter will come into the play. Now, interpreter will try to execute the code line by line, but frequently executed code will be stored and compiled by the JIT compiler. You can also say it as hot code. And for normal execution, it will directly convert it into native machine code. So why we are using JIT? So that our resources are not wasted by interpreting the same piece of code again and again. And then the native machine code that we have, it will be given to the hardware for execution. So let's see how JVM works. It is first loading the dot class file. Then there is linking. JVM is verifying the dot class file. It is allocating memory. It is replacing symbolic references and then initializing all the static variables with the values that you have defined in the static code. For example, when you will write the code, you will have variables. For example, int a is equals to 10. So that is a static initialization. You have statically said that a will have value 10. I will tell you about these things more about these things in details later on. I already told you in the previous video about stack and heap. So your static variables and all these things are stored in the stack and the actual values are stored in the heap. What is this interpreter doing? It is doing line by line execution. When one method is called many times, it will interpret again and again. So there comes in play what? JIT. There we have our JIT. Those methods that are repeated, JIT provide direct machine code. So reinterpretation is not required. This makes execution faster. And we also have one thing in Java which is called as garbage collector. Now what it is, for example, you created a code, you ran a function, and the function was run successfully, and the program execution needs to be stopped now. So what it will do, the garbage collector will come, and if uh, uh, as in the last video, I think I told you about reinitialization of arrays. For example, first we had int a is equals to array1, and we also have an array2 in our memory. Now we said that a is equals to array2. So firstly, a was referencing to array1. Now a is referencing to array2, and there is nothing in the memory, stack memory, that is referencing to array1. So now array1 is just a garbage. So garbage collector will come and it will collect it and remove it from the memory because it is now what? It is a garbage. So what we learned today, we have a Java source code. That Java source code is compiled and everything is done by for to it using our JDK, which is a complete development kit for Java. So what that does is it is going to convert your Java source code into bytecode. Now bytecode will go to JVM. Now this JVM will check if bytecode is correct, if the format is not corrupted, and if it is so, then it will go to JRE, which is going to run that Java code. I think you understood how everything is happening under the hood. Now you might wonder, why am I telling you this? See, the reason is simple. When you are learning something, you should know what is actually happening under the hood as much as possible at your level, because then you will not be shooting a arrow in the dark. Now you know how your Java code compiles, and always ensure that you know how things are happening, because a developer is not a person who can write code. A developer is a person who can actually solve some kind of a problem. Because code can be written by AI also now, and you don't want to get replaced by AI. So make sure you are learning everything. So keep learning and post your queries in the comments. Do like, share, and subscribe this video, and we'll meet the next time. Sayonara.